Hello, students. Welcome to video lesson 612B. In this video, we're going to try to apply what we talked about in our last video about sine and cosine inverse and the answers that we can get from our calculator for them, and try to look at how we can then expand what the calculator gives us to find all the solutions to any sine or cosine equation that we might run into. All right, so we're going to be going through numbers 24 and 25 in your textbook. We're going to go through them pretty much each part. So at the end of the video, you should have both of those problems completed. Number 24 starts with this equation right here. Okay, sine of x is equal to 0.3. And what they're asking us to do is find the solution, or eventually all the solutions for this equation, okay? So if we remember from our last video, one thing that we can do is we can sine inverse both sides of this equation, right? And then that'll cancel out the sine on this left side, and so what we end up with is x is equal to whatever the sine inverse of 0.3 is. Now, remember from our last video, we talked about what values we're allowed to put into the sine inverse. 0.3 certainly is okay because it's between -1 and +1. So if I just go to my calculator and I do the sine inverse of 0.3, this is going to give me one of my solutions. Again, check and make sure that you are in radian mode. Mode radian, there we go, okay. So sine inverse of 0.3 is 0.3047, about, that's what I'll put, 0.3047. So here we have x equals 0.3047. Okay, so we have this solution, this value of x that we know is going to give us a sine value of 0.3. Okay, but let's talk about where that value is on our unit circle, right? Because decimals like 0.3 or 0.3047, they're not really what we're used to thinking about on our unit circle. So let's think about our unit circle for a second and think about where on the unit circle is the sine value equal to 0.3. Well, remember the sine value on the unit circle is talking about the y coordinate of any of these points on the circle, right? So what we're really asking when we ask for sine of x to equal 0.3 is where on the unit circle does y, like does the y coordinate equal 0.3? So if you remember that up here we have a y coordinate of 1. A y coordinate of 0.3 is going to be somewhere approximately here, maybe. That might be 0.3. And so that's the y coordinate that I'm looking for. And I should be able to find 2 points on the unit circle that have that as their sine value or as their y coordinate, right? One of them is right over here. Well, I'll just draw a horizontal line through there. That'll help. So I'll just go like this, draw a horizontal line. Grab that guy again and extend it out this way. All right, so there we can sort of see now the 2 points where we intersect the unit circle. One of them is over here. So this is one of them. The other one is over here. Okay, so now let's think about the answer that our calculator gave us. Right, the calculator gave us an answer of 0.3047. So if you think about it in terms of pi, if pi is like about 3.14 approximately, if pi is about 3.14, then this is about 1/10 of pi, right? 0.3 would be like 3 divided by 10. So this is about pi over 10. So if you think about it in that way, it should make a little bit more sense that this angle right here, from the origin to that red dot, that angle has a radian measure of 0.3047. Okay, so this angle measure right here is 0.3047 radians, right? So if we think about like all the way over here to pi, that would be 3.14159 and so on, right? That would be pi radians. This little angle right here is 0.3047. radians. Okay, so you will almost always see the answers from your calculator when you do a sine inverse. They will be crazy decimals somewhere between, well, you know, we talked about, I guess, the range in our last video. In this case, for sine inverse, it's always going to be between negative 1.57 and positive 1.57 because that's negative pi over 2 to pi over 2. Okay, so you're going to get decimals like this, like 0.37, quite often. So we know that this is one of the points on the unit circle where sine is equal to 0.3. Okay, so our calculator gives us this angle right here, which is great. That's one of my two answers. And of course, from here, I could go around and around and around the circle, right, by adding 2 pi n to this number. And that would get me more answers for this point right here. But I also need to be able to figure out what is the radian angle for this point over here, right? What do I get for, like, this guy? For this angle from the origin all the way over to there, right? What is that angle? We know that this little one is 0.3047, but what is this bigger blue angle, right? That's almost 180 degrees, but not quite. And what is that in terms of radians? That's the other answer that we're looking for here in terms of what x equals, all right? So if I just get rid of these real quick, what I want you guys to notice is that when I draw this horizontal line and then I draw the two angles, these two black lines from the origin to these red dots, the angles look very symmetrical, right? It looks like basically the same thing on both sides. So if I take this angle here between, you know, the x-axis going to the left, which I guess is that way for you guys, the x-axis going to the left, and that black angle for my other side point that I'm looking for, where the sine of x is 0.3, this little angle is the same as this little angle, right? So this one here is also 0.3047. Okay, so those two angles are going to be exactly the same, just because of sort of the nature of the unit circle, all right? And they always will be the same. The one going up from this side will be the same as the one going up from that side to the same sine value, okay? So then if I think about this blue angle, the blue angle here is really the entire top half of the unit circle minus that little angle on this side, right? So if I knew the whole top half of that unit circle, I could then take away that little angle and I would have my blue angle that goes, you know, from the origin all the way around to that other red dot. So when you are dealing with the sine of x, okay, when we're dealing with sine of x, if you know one value for x from your sine inverse on your calculator, you can very easily find the other angle on the unit circle that makes you know, this same sine value by simply doing pi minus. Okay, because the entire top half of the unit circle, that would be an angle of pi, right? So if I do pi, or approximately, you know, 3.14, but we'll use the pi button on our calculator probably to get a good decimal approximation, and I take away the angle that my calculator gave me, that gives me this other red dot over here, okay? So pi minus 0.3047 will give me the other angle. So if I go here and I do pi minus, and I'm actually just going to do second negative sign to give me that answer, 0.304692654, I get about 2.8369. Okay, 2.8369. So x could also equal 2.8369. So here's one x value that would make this true, and here's the other. Okay, those two x values are the angles in the unit circle that make sine equal 0.3. Okay? Now, of course, we want to be able to go around and around and around the circle though, right? We want all of the solutions, okay? So far we've gone through letter A, letter B of number 24. Letter C says, what is the solution for all values of x? Well, in order to do all values of x, I simply just need to take each of these and just go plus 2 pi n, right? And here I'll go plus 2 pi n, where n is an integer, okay? And do remember it's important to say that, where n is an integer, right? Because I can go around 2 pi one time or two times, or I can go backwards a few times, right? So all the solutions to sine of x equals 0.3 is 0.3047 plus 2 pi n as many times as you want, and 2.8369 plus 2 pi n as many times as you want, okay? And I can sort of prove to you that this is true because I can just go sine of, let's go 2.8369. Okay, so the sine of 2.8369, I mean, if you look at that answer, it's basically what? It's basically 0.3, right? And if I do the sine of 2.8369 plus 2 pi times what n do you want? How about 4? I get the same answer, right? I get 0.299999, which is basically 0.3. So this sort of shows that these two answers, 0.3047 around and around, 2.8369 around and around, are the solutions to sine of x equals 0.3. The first answer came from sine inverse on my calculator. The second answer came from my unit circle, recognizing that these two angles are the same, so I can do pi minus, okay? Pi minus to find the other x value. All right, now let's talk about what would happen if instead of sine of x equals 0.3, what if we had the cosine of x equals 0.3? Okay, how is that different than what we've been doing? So if I get rid of all of this, I get rid of all of that, get rid of all of that. Okay, if we then start talking about not sine of x, but cosine of x equals 0.3. Cosine of x equals 0.3. Well, if I want to find one solution to this, I should be able to just use my calculator and do the cosine inverse, right? Because if I cosine inverse both sides, cosine inverse of this side, I end up, that cancels out, and I have x is equal to the cosine inverse of 0.3. This is going to take 0.3, my cosine value, go backwards and tell me the angle. And because I'm dealing in my unit circle, I want to make sure I'm still in radian mode and just go cosine inverse 0.3. I get 1.2661. 1.2661. So x equals 1.2661. Okay, so let's talk about where that value is on the unit circle, and then we'll talk about how that the unit circle can help us find the other answer on the unit circle and then the rest of the answers, okay? So now we're going into number 25, okay? By the way, this right here is 25b, x equals 1.2661. So letter A on 25 asks us to draw a unit circle and show where the cosine is equal to 0.3. Now remember, in the unit circle, the cosine value is the x coordinate, right? So I'm thinking x coordinate now because I'm dealing with cosine, okay? So the x coordinate needs to be 0.3. Remember, out here, my x coordinate is 1, right? Way out here. So 0.3 is going to be maybe right about there. Okay, so that's about 0.3, 0.6, 0.9. Yeah, that's about right. And then in order to show the two values on the unit circle where x coordinate or the cosine value is 0.3, I'm going to draw a vertical line right through that point. Okay, so I draw a vertical line, and I should hit two different points on my unit circle that I can then start to deal with. So I'm going to do these in blue. So there's one of them up here, and there's one of them down here. Okay, so these 2 points on the unit circle are the points where the cosine value is 0.3. So the first of these 2 points is found just by doing the cosine inverse of 0.3. And remember from our last video that the cosine inverse is always going to give you the value on the top of the unit circle. So it's always going to give you a value somewhere between 0 and pi, and on your calculator that's going to look like 0 to 3.14159, blah, 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 right? So some decimal between 0 and 3.14. And the first answer that we get is right here, 1.2661. So if I draw my first angle from the origin up to this blue point, okay, I can mark off then an angle in the unit circle from here to here. Okay, this angle is 1.2661 radians. Okay, 1.2661 radians. So that's one answer. The question is, how do I go from that answer to the other answer on the bottom of the unit circle? Well, it's a similar strategy to what I just dealt with in terms of the sine. If I were to draw this angle from the origin down to this blue point, hopefully you guys can see where is the angle that's precisely exactly the same as my 1.2661 from before. Well, it's right here, right? This angle here going down from the positive x-axis is also 1.2661 radians, okay? So that angle going the opposite direction is essentially negative 1.2661, right? So just so you know, another perfectly acceptable answer whenever you do a cosine inverse is the negative version of exactly what you have. Okay, so negative 1.2661 is another great answer. That is a perfectly fine representation of this blue point down here. Negative, the same thing your calculator gave you. However, oftentimes you're going to be asked to give the 2 solutions for an equation like this on the unit circle, and the unit circle is defined as being between 0 and 2 pi. Okay, so negative answers are actually not really what they're looking for, because they want the 2 values going around the unit circle from 0 to 2 pi. So how do I represent this blue point down here as a value on the unit circle? Well, if I draw for you in red sort of the angle that I'm looking for, it starts on the positive x-axis, goes all the way around, and then, you know, gets to this black line here that points towards that blue point where cosine is 0.3. So this red angle is most of the way all the way around the unit circle, right? It's over 3/4 of the way there. Now, to figure out what that red angle is in terms of radians, I just need to remember or recognize that if I were to go all the way around the circle, right, all the way around back to this beginning point, that would be a grand total of 2 pi radians, right? That's a grand total of 2 pi. And 2 pi, you guys, is approximately 6.28. 6.28. So it's obviously more decimals than that, but that's an approximation because pi is 3.14, 2 pi is 6.28. So recognize now that this red angle here is precisely all the way around the circle, that 2 pi minus this black angle here, 1.2661. So I'm really going the whole circle minus the angle that my calculator gave me to begin with, okay? Because I'm taking away this angle, which is the same as this angle, 1.2661. So to find the other value of x on the unit circle, that's a positive number between 0 and 2 pi, I'm simply going to do this. X equals 2 pi minus 1.2661. Okay, so if I go here and I go 2, and then second caret for the pi button, minus, I'm again just going to minus the answer that I have here. I get this value, 5.017. approximately 5.017. Okay, so that is equal to 5.017. All right, so this answer is between 0 and 2 pi, right? Because remember, 2 pi is 6.28. So 5.017 is between 0 and 2 pi. This answer is also between 0 and 2 pi. Okay, so those two answers are the two answers on the unit circle. Okay, so that's like basically number 25C is looking for this number right there. Okay, how did you find it? Well, we did 2 pi the whole circle minus the answer we got from our calculator. Okay, and then they want us to, again, generalize this to all the answers on an unrestricted domain going around and around and around the circle both directions forever. And so we just take the two answers that we have from the unit circle, plus 2 pi n, and this one plus 2 pi n around and around and around again. All right. Now, once you go to a general unrestricted solution to cosine x equals 0.3, it is okay to use this value instead of this value. Okay. So you can also do negative 1.2661 plus 2 pi n. So you could do, these two together would be a generalized solution. Positive 1.2661, negative 1.2661 plus 2 pi n. All right. But if you want to always use the two from the unit circle, then we would use the 5.017. Okay. So different options for representing the same solutions because they're representing the same points on the unit circle. Okay. I think that's it for this video. I do just want to summarize for you before we go sort of how this was working. Okay, so when solving sine of x equals whatever, I'll just say a. Do sine inverse of a first to find the first solution. Then we do pi minus that answer. Okay? So when you're doing sine of x is equal to some value, we have to sine inverse on the calculator first. That gives us the first answer, right? The one on the right-hand side of the unit circle. Then we do pi minus that answer. That gives us the second value on the unit circle, okay? And when we're solving cosine, of x equals a, we do cosine inverse first. And then to find the second one on the unit circle, we do 2 pi minus that answer. Okay, so when we're solving a sine equation, we do pi minus the answer to get the second one. When we're solving a cosine equation, we do 2 pi minus the answer to find that second one. Okay? If you have any questions about solving trig equations that involve sine and cosine inverse for all of their solutions, do please reach out to me and let me know. If not, that's all I have for you right now, and we'll talk to you soon.